Good afternoon. Today I am saying the concept of the probability and statistics. And today's my topic is I am discussing about random variables. Okay. Therefore, it is a part of probability and statistics. Therefore, first of all, when you go for the learning of the new concepts, first of all, you should know the meaning of the word random variable. Means here it is having the word variable. Variable means which changes from place to place. It's okay. I think that you know the meaning of this in your lower sections also. Variable means which changes from place to place. Suppose example we can say that when you take g here, acceleration due to gravity 9 meter per second square. When you go for other than that it changes. So there are, we can define as the variable is nothing but it changes from place to place. Now here it is associated with the word random variable. Therefore, to know about the meaning of the random variable, that is the definition of the random variable, will be defined as a real valued function, a mapping between S to R. It's okay? A mapping between S to R. Therefore, what is this S? This S is called as a sample space. It's okay? Therefore, when we define any mapping between sample space to a real number line, that is called it as a random variable. We define once again, a real valued function x maps S to R is called as a random variable. I will repeat the definition once again. A real valued function, if it exists such that x maps S to R is called as a random variable. For in this we can come across the word sample space. For it is generally denoted as with capital S. For how we define the sample space? We define the sample space as set of all possible outcomes. It's okay? The set of all possible outcomes of a trial. Is it okay? The meaning of trial is nothing but a random experiment. Is it okay? It is a simple word. For the sample space will be defined as set of all possible outcomes of a trial or a random experiment. For example, we can say, suppose when I toss one coin, we know that the set of outcomes that we can define it as a sample space, it can be defined as head and tail. Therefore, the sample space when you toss a coin once, head and tail. Is it clear? I think. For I can have the definition of random variable as like this: a mapping a real valued function between a sample space to a real number line is called as a random variable. That's all. Therefore, in this we can come across the word sample space. The sample space will be defined as the set of all possible outcomes. Is it okay? Before now, we can come and go to the next one. The concept of the next word is we can learn about, we can say about the types of random variables. It's okay? Types of random variables. Okay? We define the random. There are two types of random variables. There are two types of random variables. The first one is discrete random variable. Discrete random variable. Okay. The next one is continuous random variable. Continuous random variable. Okay. Random variables are of two types. Random variables are of two types. One is discrete random variable, another is continuous random variable. Before we are going to learn about the types of random variables, in general, the random variables are denoted with capital letters. Okay? The random variables are denoted with capital letters, capital X, capital Y, and capital Z, or the denotion for the random variables. But the elements in this are denoted with the small letters. Is it okay? Suppose when we have Y, you can write it as Y1, Y2, Y3 and so on. Is it okay? In general, the random variables are denoted with the capital letters, but the elements in the random variables are denoted with the small letters. Now, come to the next word, types of random variable. There are two types of random variable. One is discrete random variable, another is continuous random variable. Okay? We can define as discrete random variable as like this. This is the definition of discrete random variable. Okay, where discrete random variable, how we can define? We define it as a random variable x maps S to R is said to be discrete random variable is said to be discrete random variable if the range set is countable. Okay, if the range set is countable. And if you can understand the word countable means which is to be count, which can able to count. Okay, a random variable x maps s to r is said to be discrete random variable if the range set is countable. Therefore, I think that you can say another definition by observing this continuous random variable. We can define as continuous random variable like this. A random variable x maps s to r is said to be continuous random variable if the range set is uncountable. Okay, if it is countable, it comes under the discrete random variable. If you can't able to count, then we say that it is a continuous random variable. That's we can write the definition in another way. Therefore, if x is a discrete random variable with range set x1, x2, x3 and so on xn, it means to say that how many x1 is one variable, x2 is another variable and so on xn means there are n variables. Therefore, then we can have summation of I is equals to 1 to n, probability of x equals to xi that is equals to 1. It means to say that the sum of all probabilities is equals to 1 if it is a discrete type of random variable. Why we say that it is a discrete? Because it is countable. How many? It's varying from 1 to n. x1 is one variable which is present in a random variable capital X. x2 is another variable which is present in the random variable capital X, and so on x3 and so on. xn is one random variable which is present in a random variable capital X. Therefore, how many it is? It is having 1, 2, 3 and so on up to n. That's why when we take summation of I is equal to 1 to n, probability of x equal to xi will become 1. Okay, it means to say that if x is a discrete type of random variable, the sum of all probabilities is 1. So now we can see one problem such that you can understand about the definition of the discrete random variable. Now I am taking the problem such that you can understand it. So I am defining the problem as like this: a random variable capital X has the probability distribution function. You can write it the word small probability distribution function. Probability distribution function. It's okay. Random variable capital X has the following probability distribution function: x, probability of x equals to x. So I am defining 0, 1, 3, 4, 5, 6 and 7. So okay, we have the values below that. So it's containing as the values are 0, k, 2k. It's okay. 0, k, 2k, another one is 2k, this is 3k, this is, another one is, I am defining 3k, k square, 7k square plus k. It's okay. Therefore, what is this saying the question? A random variable x has the probability distribution function. This is distributed for how many? 0, it's there, 1, it's okay. If you want you can count 1, 2, 3, 4, 5, 6, 7. But there are totally 7. Therefore, it means to say that I is 1 to 7. That's why it is countable. That's why it comes under the discrete type of random variable. Now, what it is asking to calculate? Find k. The first one. Next, evaluate. This is the question. Evaluate probability of 0 less than x less than. I think that we can take the first question as probability of x less than 6. Probability of x greater than or equal to 6. The first is second question. Next one is third one. Evaluate probability of 0 less than x less than 6. What is x means? X is nothing but a random variable. Which type of random variable here? Which type of random variable here? Which is contained in this problem? The random variable x is a discrete random variable. Why it is discrete? Because it is countable. How many? 1, 2, 3, 4, 5, 6, 7. There are 7. Therefore, actually I varies from 1 to means I have to take this as 1, 2, 3, 4, 5, 6, 7. It is distributed. For first one, it is saying that to find the value of k. So to find the value of k, the first one is having that we know in this concept, we can write the solution as like this. We know the sum of all probabilities is equals to 1. That is summation of I is equals to 1 to n, probability of x equal to xi that is equals to 1. It's okay. When you go for I is equal to 1 to n, probability of x equals to x1. For this x1 will become here 0. x2 will become, this is 1. It's okay. How many are there? I equal to 1 to n means I can write I is equal to 1 to 7. That's why I can write it as how many? 1, 2, 3, 4, 5, 6, 7. It is countable. That's why I is equals to 1 to 7. Probability of x equal to xi that is equals to 1. It means to say that the sum of all probabilities this is. But when you go for the probabilities, probability of x equals to x1 plus probability of x equals to x2 plus probability of x equals to x3. It's okay. Plus probability of x equals to x4 plus probability of x equals to x5 plus probability of x equals to x6 plus probability of x equals to x7 that is equals to 1. Now, in the question you define this as x1, you define this as x2, you define this as x3, you define this as x4, you define this as x5, this is x6, this is x7. It's okay. Now, their corresponding probabilities. Probability of x equal to x1 means 0. Probability of x equal to 0 plus probability of x equal to x1 means 1. Before I am writing the next step, yes, like this. The thing implies I can have probability of x equals to 0 plus 1 plus probability of x equals to 1 because x2 is 1 plus probability of x equals to 3 because x3 is 3. It's okay. Plus probability of x equals to 4 because x4 is 4 plus probability of x equals to 5 plus probability of x equals to 6 plus probability of x equals to 7 is equals to 1. It's okay because sum of all probabilities. Now when you go for its corresponding probabilities is 0, first one plus k. It's okay. Next one is 2k. Another one is 2k. For another one is for x equals to 4 is 2k. For x equal to 5 is 3k. Okay. For x equals to 6 is k square. For x equal to 7 is 7k square plus k. It equals to 1. So, okay. Now when you add all this, it becomes 7k square plus k square. That is 8k square. It's okay. Next one 3, 4, 5, 6, 7, 8. I think 9 plus 9k is equals to 1. I think you can understand this term. Added 7k square plus 1k square is 8k square. 3 plus 2 5, 5 plus 2 7, 8, 9 is equal to 1. Therefore, I have to simplify this. Once if you simplify, we will get the k value. Therefore, how we can go for the simplification? This is 8k square plus 9k minus 1 is equals to 0. For I think that you can able to see this one very clearly. It represents a quadratic equation in k. Since the power of k is 2, we can get two values for k. Therefore, I think that it's represent a quadratic equation in k. Now, coefficient of k square is 8 into constant is minus 1. It becomes minus 8. For I have to get middle to be as 9. Therefore, factors for 8. Therefore, I think that I can take 8 ones 8. 8 ones 8 means minus plus is not possible. For in that case, what we have to do to? We have to go for minus b plus or minus. I think that you can see this very clearly. For because 8 coefficient of k square is 8, constant is minus 1. 8 into minus 1 is minus 8. But in the middle it is not possible to get 8 ones 8, 9 is not possible. That's why this is not possible to have this calculation. Therefore, we can go by using the formula k is equal to minus b plus or minus under root of b square minus 4ac by 2e. It's okay. I think that what is a here? A will become 8, b will become 9, c will become minus 1. I think that you know this one. When it is a quadratic expression in k, if it is not possible to find the roots, we have to go with this formula. So now what about k? K equal to minus b means minus 9. Plus or minus root of b square means 81 minus 4 into 8 into minus 1 by 2a. A means 8. For now, when you go for the simplification, minus 9 plus or minus root of 81 plus, I think minus into minus plus 32 by 16. For k is equals to minus 9 plus or minus root of, I think 3, 81 plus 3. I think that 8 to 10, 11, 113 by 16. Therefore, in this, we should get the k value. Therefore, we have to define the k value from this. Therefore, when you go for the simplification, k value will become plus and minus, but we should not consider the negative. Therefore, when you simplify, the value of k will become 0.102. That you can go with the calculation, with the calculator, for the value of k will become 0.102. When you take another with minus, you can get the negative sign for k. The negative value should not be considered. Why? Because the probabilities cannot be negative. Since the probability will lies between, probability will be negative. So probability cannot be negative. Sorry for that. Probability cannot be negative. That's why we should define the probability will always less than 1 and also it is positive. That's why we should not consider the negative value for k. I think that it's clear the sentence. Therefore, it is a quadratic, it represents a quadratic expression in k. After representing it is quadratic expression in k, it is not possible to find the roots. That's why we have gone with the formula, minus b plus r minus root of b square minus 4ac by 2a. Now what is a in this? A in this is 8, b is 9, c is minus 1. I substituted in that, I can get k. For when you go for plus root 113 by 16, I will get k equal to 0.102. When you go with the negative sign, I can get the k value is minus 1.22. Since the probabilities cannot be negative, this value should not be considered. Therefore, the value of k is 0.102. I think that it's a very simple problem. In this problem, what we calculated, since it is a discrete random variable, we calculated the value of k, for which is defined as 0.102. It's okay. When you go for the second one, I think that the third point. The third point is that what it is saying, probability of, I think that you can see, I'm writing the third one. Third one is defined as probability of 0 less than x less than 5. Means in between 0 and 5, whatever it is existing that I have to take. For in between 0 and 5, this is strictly less than. Means in between 0 and 5 should take. Means I have to consider 1, 3, 4. Put the calculation as probability of x equals to 1 plus probability of x equals to 3 plus probability of x equals to 4. Now what is probability of x equals to 1? K. Plus probability of x equal to 3 is 2k. Plus probability of x equals to 4 is 2k. So this is 5k. Because 2k plus 2k is 4k, 4k plus 1 is 5k. For 5 into 0.102. So when you simplify this, you will get the answer as, I think that 0.510. Is it okay? I think very simple. Therefore, probability of 0 less than x less than 5 is equal to 0.510. So about this one. Similarly, we can calculate the remaining. The second question, which is asking about the second point and third point. Okay. Thanks for listening.